Alright guys, so today, please watch this video and please try these problems. We're going to add on to the volume things we talked about yesterday, and we're going to talk about Cavalieri's principle, and we're going to see how Cavalieri's principle is used to determine if two solids will have the same volume, and then we'll throw in some more volume problems. So let's talk about Cavalieri's principle. I think it'll be best if we talk about it with a picture. So let me go find a picture. So this first question on your paper, it says cylinder A, which is this, and cylinder B, which is this, are shown below. What is the volume of each cylinder? What conclusion can you make? All right, so we are going to go and find the volumes of these two cylinders. Okay? So if I do the first one, then it simply says volume equals pi r squared times height, since these are both cylinders. And then we're going to make a conclusion about this. One is slanted and one is not slanted. And you notice that, one is slanted and one is not slanted. So here, let's just go and get the volume. So the radius here, they gave us the diameter. So if the diameter is 10, that means the radius is 5. And the radius is 5 for both of these. And the height is 12. So here I say 5 squared, and guys, make sure you're careful of that. That does happen. And here we get volume equals, and we're going to grab our calculator. And here I'm going to use the graphing calculator for this one. Okay, so we get, oh wow. Okay, struggle is real. Give me a second. Okay, so we're going to say 5 squared times 12. And this is 300, so we're going to put 300 pi, and this is going to be meters cubed. And you can also get the approximate answer, so I'll go ahead and do that for you too. So volume equals, pull back up my calculator, 300 times 3.14, and we get 942 meters cubed. So I have both ounces, exact and approximate. So here I have the same radius and the same height. So let's go and see here. Pi 5 squared times 12, and we get volume equals 300 pi meters cubed, and we do the math, meters cubed. Okay, so what's going on here? You notice the volumes were the same. So here is what Cavalieri's principle means. Cavalieri's principle states that as long as the base, when I should probably draw this at the bottom, the base is the same and they have the same radius, so as long as the area of the base of the container are the same, and as long as the height of the containers are the same, rather they slanted, not slanted, whatever they're doing, we know that these two volumes are going to be the same. They're going to be the same. That is Cavalieri's principle. So it means, Cavalieri's principle means, and you might want to write this down in your notes, babies, if the area of the bases are the same and the heights are the same, then the two containers will have the same volume. And that's Cavalieri's principle. So no matter whether it's slanted, to the left, to the right, stacked all kind of crazy ways. As long as the heights are the same and the areas of the bases are the same, then you know they're going to have the same volume. All right, let's go to the next problem. It says, what is the volume of the cone shown below? Okay, so the volume of a cone is equal to 1/3 pi r squared. And you do not have to memorize these formulas. It is on your formula sheet, square and then times the height. So here we just need to identify the parts. We need the radius. They told me that the diameter here is 16, so guys, please be careful. So that means the radius is 8. And here they gave us the slanted height, and that is not the height you need to use to actually solve this problem. You need the straight up height, not the slanted height, the straight up height. So we have to do some side work. So in order to answer this question, I'm going to draw this triangle because I need to figure out the height. So it told me that this side is 8, this side is 17, and I find the height here, and I put my right triangle here, my right angle there. Then the question is, what type of triangle this is? This is a right triangle. So guess what, babies? We can find the height by using Pythagorean Theorem. So I'm going to say a squared plus b squared equals c squared. Okay, I'm going to go ahead and substitute in. I'm going to call 8 a, b, I don't know, so we're going to say x squared, and c is 17 squared. Okay, we get 64. We're going to drop the line and solve the equation. 64 x squared equals $289. Okay, and then minus 64, and we're going to say x squared equals, and let me grab that calculator back, 289 minus 64, 225. So we get x squared equals 225, and we don't want x squared, we want x. So square root of 225, and x equals 15. So we found the height. So we know this height right here is 15, and this is what's going to help me get my volume. All right, and I'm going to go erase all of that and just go and rewind the video if you need to copy this down, or if you need to go back and think through it. I need the space, so I'm erasing it, babies. Okay, so let's keep my little line going so I keep my space. So I know the height is equal to 15. Now I can go and solve this problem. So volume equals 1/3 pi 8 squared times 15. And here I'm going to go ahead and graph my calculator to help me out. So clear this. Alpha y equals, enter, so 1/3 8, and what was it, 15, push enter, and you get 40. So the exact answer is 40, and we're going to say centimeters cubed, and the approximate answer would be 40 times 3.14, and we get 125.6, and that's centimeters cubed. And we're finished, babies. Okay, so now let's go to the next one. It says, and here we go, we're going to read these sentences, we're going to circle what it's about, and we're going to underline what that something is doing. So here we go. It says a cylinder has a radius of 10 centimeters and a height of 9 centimeters. Okay, a cylinder has a radius. Okay, so this is about a cylinder, and it has a radius of 10 centimeters. That's important. And then it says it also has a height of 9 centimeters. So that's my first sentence. Now it says a cone, and I'm going to just do a different color so you can see what I'm doing. A cone, so this is about a cone now, has a radius of 10 centimeters. That's important. Well, that's what it's saying about the cone. And also about the cone, it has a height of 9 centimeters. So it says, show that the volume of a cylinder is 3 times the volume of the cone. So we just need to do the math. So we want to show that the volume of the cylinder is 3 times the volume of the cone. Okay, so let's go here. So I'm going to draw a picture. Pictures are your best friends, and so make sure you draw them. So it says I have a cylinder, and it says a radius of 10 and a height of 9. Got it. Now it says I have a cone, so I'm going to draw me a cone. It says it has a radius of 10, so 10 here, and a height, which is the vertical height and not the slanted height, of 9. Okay, so I need to work my two formulas. So I'm going to go with the volume of a cylinder first. I'm going to change the color, babies, which is pi r squared times height. So volume equals 10 squared times 9, because here is, and if you need to write it out, radius is 10, height is 9, and that's for both of them. So here, let's do the math. I'm going to get 900 pi, and you can use your calculators, babies. And the units here is centimeters cubed. And you're going to go 900 times 3.14. 2,826 would be the approximate answer. Centimeters cubed. So there's your volume. So that's the volume of the cylinder. I'm going to put C right here. And now I'm going to go do the volume of the cone, and then we'll go back and answer the question. So volume of the cone, I'll do next, is 1/3 pi r squared times height. So volume of the cone would be equal to 1/3 pi 9, oh my bad, 10 squared, that's the radius, times the height. So we end up with volume of the cone is equal to 300 pi. And you can use your calculator to see how I got 300. And how I got it was 900, this is 900, times 1/3 is 300. And then I get 300 pi. And that would be centimeters cubed. And if I keep going, volume of my cone would be 300. We would get 300, so clear 300 times 3.14, and that would be 942. 942 pi. I mean, not pi, sorry, I already did pi in there. This is my approximate answer, centimeters cubed. Okay, so here's the volume of the cylinder up here, and down here is the volume of the cone. So if you look at this, it says show that the volume of the cylinder is 3 times the volume of the cone. So look at here. If I compare these two, if I say that this is 900, then in the volume of the cone is 300, then all you have to do is say what times 300 would give you 900. And that's when you can say 3 times the volume of the cone will give you the volume of the cylinder in this case. So all you say 300 pi times 3 will give 900 pi, and I'm using the exact answer to talk because it's just easier for me to use that one. You can use the approximate answer too. Would give 900 pi, which is the volume of the cone. I mean, not the cone, but the cylinder. Volume of the cylinder. And we're finished with that one. Okay, so let's go here. It says, Jason constructed 2 cylinders using solid metal washers. The cylinders have the same height, but one of the cylinders is slanted as shown. What can you say about the volumes of the cylinder? And because of Cavalieri's principle, all of these are still made of circles. So there's a circle on the bottom, so that means the area will be the same. And if you look, this height is going to still be the same as this height. They just pushed it over. So we're going to say volumes are the same. So how much both of these hold is going to be the same. And we're going to say because of Cavalieri's principle. And we're finished. It says, what is the volume of the cone shown below? So here's a cone. So volume equals 1/3 pi r squared times height. And remember, babies, you do not have to memorize these formulas. It's on your formula sheet. So here, radius is 4. And this time, ooh, we're in another situation. They gave you the slant height. That's not the height we want. We want the straight up height. So guess what we have to use? We have to go use Pythagorean's theorem. So in order to get the volume to help us get height, we have to go to Pythagorean's theorem. So we're going to say, because we need this side, we're going to say a squared plus b squared equals c squared. And eventually you'll start getting used to seeing these Pythagorean's triples. So if you see a combination of a right triangle with 4 and 5, you automatically know the other one is 3. But if you forget, I'm showing you the math here. So I'm going to say x squared plus 4 squared equals 5 squared. So x squared plus 16, drop the line, equals 25, minus 16 minus 16, x squared equals 9. X equals 3. All right, so we have the height of this triangle, which is 3. Okay, so now we know that height is 3. And guys, if you need that, just go back and record it. Pause it so you can see it again. So the height there is 3. So now I can find my volume. So here, I know this is 3 now. And remember, if you see these Pythagorean's triple, you know those by heart. Just roll with it. So 1/3 pi 4 squared, oops, I shouldn't have put that there. It should have went up there at the top, times 3. So here, volume equals, what is this going to be? 16. 16 times 3 is 30, 48, and then 48 divided by 3. Let me grab the calculator. Or you can put this directly in the calculator. Let me go ahead and show you. Alpha, I was going to use my mental math. Anytime you can try to use your mental math, try to use it, babies. And if you use the calculator to check yourself after you've done your mental math. And that's 16, so 48 divided into 3 is 16. So we get 16 pi, and what are the units? Centimeters cubed. That is my exact answer. And let me go get the approximate answer. Times 3.114 equals 50.24. And this is centimeters cubed. And we're done. We found the volume. I think this problem right here may be a duplicate. Yeah, it's a duplicate, so you can skip this one. Okay, let's keep going. Okay, so Alexis created the following 3 solids. What can you say about the volumes? And we're going to say, well, they all have a base of a rectangle, and they all seem to be the same height. So we're going to say the volumes are the same, and because of Cavalieri's principle. because of Cavalieri's principle. Okay, so let's go to the next. What is the volume of the cone shown below? So here, we have the radius to be 6, but once again, we are missing the height. We're missing the height right here, babies. So because we don't have the height we need, we have to use Pythagorean Theorem again to help us get where we have to go so we can get the height. And this isn't a familiar Pythagorean triple to me. But as you keep doing them, you'll start learning. I think this might be a double of the Pythagorean triple. What is this? Double? Okay, so my estimate, well, my guess at this is going to be 8. So we're finna get ready to see. We'll call this x, so I'll say x squared plus 6 squared equals 10 squared. Drop the line, so let's go for it. Plus 36 equals 100. And I'm going to minus 36, so I'm going to use my mental math to help me get where I have to go here. X squared equals, what's this, 4. This becomes 10. And this becomes 9, so 64. Oh, I was right. It's going to be 8. And I'm going to tell you guys how I figured this one out, so you can know too in the future. I want to show you. So x is 8, and I predicted that was going to be 8 to start with, because here's what I noticed. This is a Pythagorean triple, and this side right here, I noticed that this was a double of the 3, and this is a double of the 5. So I just predicted this was going to be a double of the 4, and that's how I knew it was going to be 8. But you don't have to necessarily know that. You could just do the math, babies, and see what the height is. So the height right here is 8. So now I can find the volume. So let's go and make that do what it do. So here volume equals, and since this is a cone, 1/3 pi r squared times height. You do not have to memorize this formula. This formula is on your formula sheet, sweethearts. So volume is 1/3 pi 6 squared times 8. So volume is 1/3 pi 36 times 8. That's going to be 180 plus 48, which is 228. And then 228 divided by 3 is 76 pi. So I'm going to go ahead and say 76 pi. And I'm going to double check my math. Make sure I'm good. So 36 times 8. Oh, it's 288. Divide that by 3. Okay, it's 96. I was short. So this is 96 pi. And y'all, try to exercise your mental math just to make sure your brain is still working in that capacity and it's not totally dependent on the calculator. You can go and use your calculator to check, but mental math is good to know how to do also, just to keep your brain exercised. Okay, so we get 96 times 3.14, and that is 301.44. And this is inches cubed. So you got both ounces, approximate and exact. So here we have a situation. It says a sphere. So we're talking about a sphere here, and it has a radius of 4. So the sphere, and what's going on with the sphere? Radius of 4. What happens to the volume of the sphere if the radius is doubled? So it wants me to find out what happens to the volume of the sphere if I double the radius. So let's find the volume of the sphere to start with, though. So it's 4/3 pi r cubed. Okay, so we say volume equals 4/3 pi, and our radius here is 4 cubed. So we get, if I do my mental math, I get 4 times 4 is 16 times 4 again gives me 40 plus 24, which is 64. And then we do 64 times 4/3. All right. Or you can just straight up put this in the calculators, babies. I'm just using my mental math. difficult. Because that's a good practice for you guys, is keep your brain sharp. Try to use your mental math when you can, and then just go and check yourself. So we get 256 over 3 pi, and it didn't give me units, so we get units cubed. And let me make sure I did my 4 to the 3rd power correctly. Yeah, I'm good. Okay, and then I can take that to get the exact answer, the approximate answer. So 267.95. So volume is 267.95 units cubed. Okay? And that's the volume of the first sphere. Now he said, what happens if I double the radius? So the radius in the first problem, the radius 1 in the first problem was 4. If I double this, double means to multiply by 2. So that means my radius 2 is going to be 8. So here, I'm going to do the volume of the sphere again, and we're going to see what's going to happen. So volume, and this is the second sphere. So we do 4 over 3 pi r cubed. So volume equals 4 over 3 pi 8 cubed. And I'm just go ahead and use the calculator so you can see both ways, mental math and this way. And raise to the 3rd power. So we get 2048 over 3 pi, and it's units cubed. And to get the the approximate answer, then I take that, multiply it by 3.14 equals, oops, units cubed. So it says what happens when it's double. So let's go and see. If I look at this one and this one, I am going to, it looks like it got bigger from what I'm looking at. So let's see. Let's see what happened. I'm going to take this volume and divide it by that volume to see what was the factor between the two. So 2143.57 divided by 267.95 equals, looks like it's more, it's like about 8. So it seems like the second volume is 8 times, and times means to multiply, 8 times more than the first volume. Okay, so it's 8 times more than the first volume. And we are done. We're done with this one. So we explained that. Let me see what's next. Okay, so it says Imani and Takwila were having a conversation about the solids below. Imani said the volumes are not the same. Takwila says the volumes are the same. Who is correct? So in this case, Takwila is correct. And she's correct because the bases are the same. They both have triangular bases at the bottom, and they're the same height. It doesn't matter what's going on with the shape. It's like at the grocery store. If your can get bent up, you still have the same amount of stuff in the can because the height didn't change. You just bent it up some. So we say Takwila is correct because of Cavalieri's principle. And what that means, if the area of the bases are the same and the heights are the same, then the volume is going to be the same. So Takwila is correct. What is the volume of the cone shown below? Well, we're lucky this time. Look, y'all, they gave us the slant height. So we don't have to deal with Pythagorean Theorem. We can go straight into this. So the radius is 8 and the height is 15. So we can say the volume of this cone is 1/3 pi r squared times height. So volume equals 1/3 pi 8 squared times 15. Okay, and I'm going to graph the calculator. Alpha y equals, enter, 1/3 times 8 squared 15, and that's 320 pi meters squared. And if we want to get the approximate answer, then you take that times 3.14 meters squared. And we are finished with this one, babies. So here we go. These two are our approximate and exact answers. So here it says a cylinder has a radius of 5. So this is about a cylinder, and guess what? Its radius is 5 inches and its height is 7 inches. This is what is going on with the object, the cylinder. It says if the radius is tripled, so we want to triple the radius, what happens to the volume? Okay, so we're going to draw a picture. So we have a picture, and we have a radius of 5 and the height of 7, and it wants to know what happens if I go and draw another picture and make this one 15, because tripled means to times by 3, and we keep the height the same. So let's go see. We know they're not going to be the same because the area of the base is not going to be the same, so we can't use Cavalieri's principle for this one. So volume of a cylinder, we're going to do the first one. First volume is pi r squared times height. So volume is pi 5 squared times 7. Volume 1 would be 25 times 7, 135. 25 times 7, no, that's going to be 140 plus 35, which is 175 pi. And then I'm going to go ahead and check my math too. Brain getting tired, y'all. 5 squared times 7. Okay, 175, I'm okay, times 3.14. So we get an approximate answer of 49.5. And this is inches cubed. Inches cubed. That's the first volume. Now we're going to go get the second volume, and we're going to see what happens if I triple that radius. So volume 2 is going to be pi 15 squared times height. So we would get, let me grab the calculator. 15 squared times 7 equals 1575 pi. And I'm going to get, and that's inches cubed, and I'm going to go get the approximate answer. 4945.5 inches cubed. Okay, so now we got to see what happened. And I'm going to compare the exact answers. So I get 1575 and 175 pi. So I'm going to go and divide the big one by the little one, because I went from a big volume to a small volume to a big volume. So that means I want to find, is there a scale factor? Since I went from small to big. Ooh, I have a scale factor of 9. So what I can say is if you triple, so here's a statement you can write. If the radius is tripled, then the volume will be 3 times, which means it will have a scale factor, or 3 times as much. So here I found out if I take this and multiply by 3, I get that because I went from a small volume to a big volume. So it's kind of like the same concept as scale factors, how you go from a small picture to a bigger picture. So you're looking for the k to be greater than 1. So here, I found that if I put the big number on top and put the little number on bottom, then I can see how I went from a small picture to a big picture. Okay, let's see what else we have. All right, so I want you guys to answer these questions, and we'll talk about them tomorrow. Bye, babes.